In this video, we're going to start our discussion of the topics of Chapter 7. It's important to note that right away, nothing in Chapter 7 is going to directly relate to what we've been dealing with in Chapters 5 and 6 in terms of sequences and series and power series. But the material presented here in Chapter 7 is material that is going to be very relevant for those of you moving on to Calculus 3. Because all of the topics that we will talk about in this chapter, in Calc 2, is a two-dimensional variant of what you will expand upon in Calc 3. In Calc 3, you will enter the world of three dimensions and begin to discuss these same ideas in 3 space. So we begin here in 7.2 by making a pretty obvious observation that, as I state here, not all curves pass the vertical line test. We know this. You can think of curves like a circle or a curve that loops back and intersects itself somewhere. And it's possible that these curves can be described, but certainly not with a function like a y equals f of x. That's not possible, because if they don't pass vertical line tests, these curves are not functions. So the idea in this section is to express these particular curves in the xy plane with what we call parametric equations. So here's what we have. Let's suppose that x and y are given as functions of a third variable that we'll call t, which is referred to as a parameter. Okay? So ultimately what we're really saying here is that we're going to imagine that, let's suppose that to describe one of these curves that is not a function, we had some new formula with t's in it that told us x coordinates, and some other new formula, call it g, with t's in it that tells us y. And when we put these things together, we call these parametric equations. Now, each value of t that we plug into one of these formulas is going to give us a value of an x and a y, and that will allow us to plot points. And when we plot all of the points in for all values of t, then we'll create what we refer to as a parametric curve. So I'll summarize that by saying that each value of t will produce a point x comma y, and all values of t will, in a sense, produce the graph of the curve, which is what we refer to again as a parametric curve. So we're going to see some different examples here, and I'll start with example number 1 of how some of these curves look and how I can imagine dealing with their functions. So sketch the curve that's given by these parametric equations. So you'll see here I have a formula with t's that is determining x, so this is kind of like my f of t formula over here, and then I have a g of t formula, which is this t minus 1. Now, if I wanted to go ahead and try to sketch this curve, I would do the same thing I did back in a basic algebra class. I would start by making a table. Although over here, I'm going to have to make a table that has 3 columns in it, because I'm going to have to plug in a value for t, and then get back something for x, and something for y. So I'm going to go ahead and just pick a whole bunch of different values here for t. How about I start at -2, and I go all the way up to, how about I go all the way up to 3, something like that. So if I was to do this, I can easily determine with each of these formulas what I'm going to get for my x's and my y's. Now I'm going to fill out my y's first since they're so simple. I notice that I just take my value of t and I subtract 1 from it. So of course all my values are going to look like this. The t's values when plugged into the x formula are a little bit more complicated. You can double check me, but I believe that I get a value of 8, 3, 0, -1, 0, and 3. And so if I was to put all of these together in one picture, I would create something that looks like this. Again, this is my basic xy axis, but I'm about to sketch the picture of something that is likely not a function. Now, I'll notice that over here I have my x and y pair. These are the points that I need to plot. So let's suppose that this is the value of 8 out here. Let's suppose this is the value of -3, and so I'm going to have a point right here. I'm also going to see that out at a value of 3, -2, which we'll assume is over here. Let's assume that this is 3. I'm going to get another point. I can see that 0, -1 is a point. I can see that -1, 0 is a point. 0, 1 is a point. And 3, 2 is also another point. Now, if I was to kind of put all of these points together and imagine connecting them with a curve, it's probably not too big of a surprise to see that what the curve is that I'm likely dealing with here is some sort of like sideways parabola-like graph, which of course we can see is not a function. Of course, my line here is a little bit iffy in terms of it's not very smooth, but hopefully you can still see the general shape that we're going for. Now I can imagine this extends, and I can see that this is a curve then defined by these parametric equations up here. If I was to take a look down at part B on the next page, I could see that it's actually possible to describe this curve with a single equation which does not have the parameter t in it. Now it's important for me to note what the original formula for each x and y actually were, so that way I can see how I might be able to better do this. Again, I'm looking to try to go ahead and replace out or substitute out all the values of t, so I only have an equation with x and y. Now to do this, it's pretty easy to go ahead and note that if y is equal to t minus 1, then t would have to be equal to y plus 1. So if I was to actually go to my x equation, which is t squared minus 2t, I could replace t with what I know t is equal to, which is y plus 1. So I could replace that with y plus 1 squared minus 2 times y plus 1. And so I can see that ultimately I have a formula that contains only x's and y's and no values of t. And so sometimes this sort of like maneuvering of one formula to get t isolated so you can plug it into the other is a great way to accomplish this task. What you'll notice is that this is indeed going to be a sideways parabola. I can see that I'm going to have a y squared term that's going to have a positive coefficient, and so I know it's going to open to the right. In the next video, we'll take a look at examples number 2 and 3.